Hi, my name is Eurico Costa, and this is the final presentation for the CIT 260 spring semester 2015. And I would like to start this presentation by talking about static versus non-static instance variables. Static variables refer to class members that can be used independently of any object of that class. Usually a class member is used by referring to an instance or object of its class, but it is possible to access a member of a class without creating an instance of the class. To do so, we precede the declaration of the class with the keyword static, as in the example here, public static player, create player. That's a declaration of a static method of a class. When a class member is declared as static, it can be used without creating an instance of a class. In the example, in usage, I have player, which is a variable of the type player, that it's being assigned the value of the static method create player. So we're not instantiating program control, we're just calling it directly, and then calling the create player method and assign it to player. So that's an example of how we can use a static variable. The other example below, the non-static, so basically whenever we have a variable that it's non-static and we want to use a member of an object that it's non-static, we need to instantiate the object, as an example here, game menu view, game menu equals new menu view. So we're basically instantiating an object of type game menu view and assign it to the variable game menu. And then finally in usage, we can use the game menu dot display method. And that's the difference between static and non-static instance variables. The next item is lists within Java. So there are several types. We addressed array lists, and enums. The arrays, they are used when the list that we want to handle has a fixed length of objects. And all the objects are of the same type. Objects are primitive values. They're all of the same type. They can change during the execution of the problem, the content of each of the array positions, but the number of items within the array remains the same. In the example that I'm using here, it's an array of objects of type location that has actually 2 dimensions. Array lists are used when we have variable linked lists, meaning that dynamically through the execution of the code, the size of the length of the list can change. And array lists has an add or remove method to be able to dynamically add or remove objects. It can have objects of multiple types within the same array list. And there's an example of how to instantiate a variable of type array list. Enums is a special type of lists. They have a fixed length. All the objects in the list are of the same type, and they don't change. They're constant. So in the example that I use here, basically we're creating an enum of type called item that has the objects that are between brackets in it, or elements, let's say. And it can be used, for example, if you have a variable within an object that has, determines a category of objects, and you could say that the object is of type item.ax or item.rope or things like that. It's just one of the possible usages of enum. The next item that I want to talk about is the for statement or a for loop. A for loop, it's a structure that is used to iterate through code, just repeat code within a program. In this case that I'm showing here, it's a for loop enclosed within another for loop used in the method, in the class game menu view method display map that is used to display all the locations within the map. And it basically demonstrates the usage of a for loop. And the for loop, the header statement is defined by a variable that contains the index, in this case row, a condition that is used to determine the limit until when the for loop is going to be executing, which is in this case is row less than locations index 0 dot length, and then the iterator, which through each cycle of the for loop is going to increment until it reaches the condition determined in the header. In this case, the for loop goes to the first position of the array, which is within the row of the array, and within that row, it goes through then the second for loop, which goes through each column of the array. It looks at the content of the location object, gets the location object, and then it prints a symbol based on the condition in the first if. In this case, if the actor is within the location that we are currently iterating to, it shows the character, the hash sign. And if not, if the variable location.get visited is true, it will print a v. If it has nothing, so the position hasn't been visited yet, it's going to print those two question marks. And it continues through the loop until the whole array has been navigated through, and it prints the map. And that's it for statements. The next item is error handling and how errors, how try catch works, and how can we handle runtime errors. So to handle runtime errors, we need to write code specific to catch these errors. To do this, we enclose the code prone to error in a try-catch structure, as in the example here. In this example, we are opening an output stream, a file output stream, and attempting to write a file to the system, trying to create and write the file. If there's an I/O exception, for example, the path is not found, or for some reason the file cannot be opened, then an I/O exception is caught, and then the way the error is handled is by throwing a game control exception in this case. So this is how we use a try-catch structure to handle runtime errors within an executing program. Now, runtime errors that are not caught by a try-catch statement need to be propagated up the calling hierarchy, so they can eventually be handled with a try-catch statement in the function higher up in the calling stack. Runtime errors are propagated up the calling stack by adding a throws clause to the end of the function signature of every function in the calling hierarchy that is not handling the runtime error. That way, defining that the errors that are to be propagated back up to the calling function. Adding the throws instruction at the end of the function signature tells that any function that calls that function, that they have to handle the runtime exception with a try catch, or they need to propagate it up the stack until there's finally a function that actually again captures the error and handles it correctly. In this case, in this example, we're saying that the create new game method throws the map control exception in this case. Okay, next item, character streams versus byte streams. A byte stream reads and writes binary data 1 byte at a time in a sequential order. They're used to read and write binary data, they can also be used to read and write character data stored in ASCII format, which maps each character to a single byte of data used only by Western-based languages. Java, however, stores character data in Unicode format, which has 2 bytes of data, and can handle all languages, not just Western languages. So Arabic, Russian Cyrillic characters, Japanese characters, and things like that, they can be handled by Unicode. A byte stream, so because it only reads 1 byte of data at a time, it cannot read Unicode data. So to resolve this, Java added the character stream classes that can handle both Unicode and ASCII character data. There are several examples of character stream classes, such as buffered reader, buffered writer, char array reader, and char array writer, file reader, and file writer, etc. These are just examples of how of the streams that character data can handle. We would use character data streams to write to files because, first of all, it can handle all those languages and characters. It is very efficient in how it writes large volumes of data to a file. The next example demonstrates or shows how a file can be written. In this example, it's an example I created to print an actors report. The first thing it does, it's here, it's in the console, ask the user for a path where the file will be located, and then it creates an instance of a file object pointing to the file path that was provided by the user. It opens a file stream, for this case, a file writer stream, to hold the data of the file, and then it starts writing the characters or the content to the file using the write method. I instantiate the map, I get the locations in the map, and then I go through each location in the map and see if there's any actors contained within the map, within the location object. And it writes the actor name plus the row and column where the actor is located. At the end of this process, when everything is written, we call the flush method, which basically empties the stream, the queue where all the data is, and writes everything to the file. And then I go through a process where I actually open the file and show the content of the file to the screen. To close the files, again, I've got error handling to handle any type of IO errors, IO exceptions that happens during this process. And finally, even if something happens, if there's an exception, the finally statement is the last to be executed always. So it tries to, first of all, see if the file exists or not. If it exists, if it's open, it was successful, then it tries to close the file. And that's basically the process to close and write the file. I will demonstrate how this is handled in my program. Java.jar cold. Enter my name. I start a new game, and in this case, I select option R, which will print the actors' reports. I enter the location where I want to put the file, and in this case, first I'm going to demonstrate an error. So let's say I will try to put this in a path that does not exist. TXT actually. And so in this case, the path does not exist, so it throws a no such file or directory. So I'm going to try this again. I'm going to again select option R. So now I'm going to use a valid path. downloads actors report.txt, and now it found the path and it actually printed the list of actors. If I now go to this location, I will find the file that I just wrote. Which is I believe it was this one. Let me confirm. Downloads actors report.txt. No, it's this one. Okay. So here's the list of actors that was written. There's a concatenation in the list, in the name of the file, that because I added a name of a file and then the code concatenated something else. And that's it for writing character data to an external file. Now, unfortunately, the game is not complete, so we weren't able to complete the full game. But I would like to demonstrate some of the capabilities that we have created in the game. So first of all, executing the game and the entrance banner, entering my name. So creation of a new game, it's working fine. I can display the map and shows my initial position by the ash character, and now I can move the object, the player around, and do, for example, let's move the object, the player to the right, and again to the right, and again to the right. And if I try to move it again to the right, it's going to tell me that it's not able to move the player again. So the navigation through the building is working as it should be, but unfortunately we weren't able to complete everything else in the game. We have, for example, so the navigation is working, entering through, for example, at this door where we at, if we try to enter through the selected room, we can enter, and then we can, for example, remove an obstacle, and we can search the room, although some of these functions are not implemented. So unfortunately, we didn't have all the time that we needed to complete this, but the code and all the lessons that we went through taught us, quite a bit about Java, and I hope I was able to demonstrate it through this this presentation. And that's it.